when I do a talk at Radio Club, I appreciate there's people been doing this a lot longer than I have. But there's also a lot of people on the internet, and there's a lot of people that are fairly new to the hobby, or there's a lot of people that have just experienced other things in life. They just like to be inspired and have some inclination towards, other things. So if you haven't before got on HF, then, hey, let's just have some fun on HF. So I just want to talk about ATUs a minute. So when I first got licensed, I absolutely thought I needed it was a Yaesu FC102 or something. It matched the FT902 or the FT101, the original. A lovely little tuner. But looking back, I sometimes wonder why I had it, because a tuner, let's just think about this. So if we've got a dipole for 40 metres and you've got the space for a whole dipole on 40 metres, I dropped my pen a minute ago and I'm just making sure I know where it is. Then you just don't need a tuner at all. So, and the tuners that I'm particularly talking about is not a balanced tuner which has like to run a doublet. So that's ladder line all the way back out the tuner, along the wall, out the wall, up the backyard, the garden, whatever, to a balanced, to a doublet. What I'm talking about is the sort of thing where you have some weird contraption in the back garden, and you've got your coax between the radio and this tuner. And then you have another piece of coax from this tuner to the back garden, and we go about tuning the nuts off it. Excuse me, I had some crisps and some beer earlier on. Tuning the nuts off it. Now, as an interesting point here is that I was running 80 metres one day, and there was a fella who told me he had a 160 metre dipole, full sized, and he had a coax tuner on it. Okay, in other words, you got the radio, the coax, the tuner, then a long piece of coax, and he's 160, and he was probably very efficient on 160. He might need to tweak just so the radio itself saw a nice SWR, but ignoring that, he hit me on 80 metres, and he was an extremely weak signal. When most 10 watt stations were like S7, S8, he was, and he was from a part of the world that I'd had Mike 7 foundation students on foundation passes on 10 watts. He hit me at 400 watts on 80 metres, but he got a perfect tune. He was quite happy telling me that he had a perfect tune on the 80 metre band using this tuner. And of course, it just surprised me, because I think he might have even been a G3, and I thought that, but the old timers who passed the original RAE probably had a harder time getting on the bands than we did in my environment. And I was just quite surprised that he was certainly a couple of S points lower than them, running 400 watts. So how much of that was being converted to heat? So I invite you, if you do use a tuner with a coax fed antenna, to reconsider, can you change the shape, the size, and what are you doing? So I'm going to get my pen, hang on. So I was fiddling with it like an ADHD boy in the back of class, which I was for years. So I've got a few conditions, as a few of you know. Where can we take this? Well, we're going to get to some strange shapes in a minute, because I'm fascinated in the ability to get down to the lower bands if you can't squeeze it all in. In other words, you've got a backyard or a back garden that's too small for 80 or too small for 160. What are the sort of things we can do to get out? You might not be the strongest on the band, but you can still receive very well and you can still transmit fine. And we'll just start off with 80, all right? and we'll have an inverted V. I always draw the left hand one a bit smaller for 80. And we know that if this really was 80 meter band, that give or take, well, I know depending on the height above ground and a few other things, this is going to be probably about 19.5 meters long each leg. Now, if you're in the US, and I don't think anybody on the club tonight is in the US, but the US band, some of the license conditions start at 3.8 and go up to 3.9. Some people start at 3.5 all the way to 3.9, maybe even a bit more, I don't know. That is a huge band. That's why sometimes the Americans call it the 75 meter band, not the 80 meter band, because it's enormous. So to get an 80 meter dipole into there is a bit difficult. However, let's just look at the maths behind here. So if this is, what's the length of that going to be? Well, if it was flat, it's going to be 40 meters long. Now, and it's not flat, so it's going to be about 35 in total, end to end. Now, I don't know about you, but my garden is 10 meters deep and about 13 meters wide. But I still got on 80 quite happily without using a tuner. And that's the point. Because Rowley, ZL1BQD, he calls it, I can't remember what he calls it now, some sort of, dummy load, basically. What you're doing is you're sucking out all the power, basically. Matching it in this unit, converting it all to heat, and then getting some of it out into the coax without being technical. Because a lot of people know I don't use technical words if I can help it. I like just talking in English, which is why I say, for instance, if anybody ever asks you, what a ham radio, what is it? Why do you have all these different antennas? And I tell them it's like playing a piano. So the long notes, the long wires in a piano play the low notes, and the short wires in a piano play the high notes. You can't expect the low one to sound very high. It would need to be shortened. It's just the same. Amateur radio is the same. So it's like playing a piano. So that's why we have, right? And I'm just getting you to rehearse this because I'm sure you've been caught in a pickle. I was for my accountant who wanted to know why a DX commander had all these wires sticking up it. I had to explain to him that they're all the different notes on the piano, and very often different octaves as well. Which we'll get to. Incidentally, if we look at our 80 meter antenna, which is, let's say 3.75 megahertz. Now I'm doing some maths in my head here, but 300 divided by 3.75 is 80. So in fact, that really is the 80 meter band, 3.75. Now, if anybody's got a calculator here, we could probably do this, but I'm not going to do the third harmonic or the fourth harmonic. The third harmonic is about, I seem to remember, about 18 point something, question mark. So your 80 meter antenna will actually resonate again on the 18 or 17 megahertz or 18, whatever it is. 17 meter band, isn't it? 18.15 or something. Not quite. Okay. So this is the point where sometimes you do need a tuner because you're not far away. You know there's some resonance there. You just need to keep the radio happy. So I did a video once saying, watch this before you buy an ATU, and then you get all the people, don't you? Complain. I get people complain about everything I ever say. The 80 meter band is very, very particular in that it goes genuinely from 3.5. So if you're a CW up and you're doing SSB, there's no way you're going to get one antenna unless you fill it with 50 ohm dummy loads to go from 3.5 to 3.75. But if you've got enough in the air, you'll find the SWR isn't actually that high each end. It's not like it's infinite, or it's not like it's the second harmonic. So it's a 160 meter, which should not and will not resonate at double the frequency. It's thereabouts. So to keep your radio happy, just stop it, because a modern radio will just back off, won't it? Then you can use your ATU. Yes, if you really must do. If you're only a 100-watt station, you'll find that your inbuilt ATU will soak that up anyway, and no one will ever know. So I'm not saying never buy an ATU, all right? What I'm saying is, other than 80 meters, maybe 160, you shouldn't ever have to have an ATU. Right, so my inverted V dipole at home literally did this. In fact, it came along a fence, and that got me on 40 meters. So they had a little fiberglass pole here holding it up. That was 6 feet off the ground here, and I just ran these and cut them back and got it to resonate on 40 meters. So that's fine as well. 20 is easy, of course, because we can make a fan dipole. And I don't like. It's like flogging a dead horse sometimes. I suppose I've done 700 and something videos on YouTube in the last 4 years. Now, I'm aware that only I'm probably the only person that has watched them all because I made them. But it's getting to the point now where I think, well, I've said this 10 times, but I have to remind myself that I might have said it 10 times last year, but people, new joiners, probably haven't looked at my back catalogue, and who in their right mind is going to watch 700 videos anyway? So I apologise if I'm what they call flogging a dead horse. In other words, I'm going over and over the same ground sometimes. So a fan dipole, one of the reasons a fan dipole works is if this is 40 metres, and these will be about 10 metres long, and that's a 20 metre element, they'll be 5 metres long. Now, there are people out there in the world that actually think we've got some contraption at the feed point. We don't. It just works. If you put a 40 metre dipole and a 20 metre dipole and connect the two together, so we get our coax. There's our coax, and we've got the braid here, haven't we? There's a dielectric in the middle. So that's the shielding. And our dipole goes that way, and the braid goes the other way. And that's kind of the circuit. Nice and simple. All we need to do is connect a 40 and a 20, and you're on 40 and 20. That's it. Incidentally, if you did go on 40, you'd also be not far off the 15 metre band. And there is a trick. If anybody wants to ask me about that trick, I'll tell you after the presentation. So there we are. And 20 will give you 20. Unfortunately, the next harmonic is 3 times the frequency you're on. So if we're on 14 megahertz, what's the trick? Let me get rid of Frank. So if we've got if that is resonant on 14 megahertz, if we multiply by 3 fours are 12. So is that 42 megahertz would be next resonant? And in fact, it's not. It's not actually resonant on the third harmonic. In reality, it's third and a bit. It depends on height above ground and a few other odds in it. Fan dipole, nice and easy. However, I'm not here to talk about that. We were going to talk about strange shapes. Incidentally, we'll go up. No, we won't. We'll start a new piece of paper. Height above ground is really important. So I've got a presentation coming out after the 13th of October, and it goes into about height above ground. It's not until you go about half a wavelength above ground that you will beat a vertical in 2 directions. Just a straight vertical. And we'll do a straight vertical in a minute. But I didn't know this. So what I did is I had my house. I thought, I know I could be really clever. And I could get a couple of meters extra height. This would be fantastic, this will. So I created a Z-shaped 40 meter dipole. So these, I don't know, were 10 meters or so. I can't remember. I was going around chopping bits off and adding bits on just to get them to work on 40 meters, this thing, right? And it went quite high because in 3D it was like this and then went like that, But all that happened, to be honest, is I got more noise because I was right above everything, and I'd set the house alarm off. So that's still up there, disconnected. But then it got me thinking, because in my garden, I'll do a plan view, okay, looking down, right? So I've got the back of my house here. And what I did is I came up with I put a banister rail, actually, made of wood, right? Now, was I some sort of skinflint? I think I was. We had kids and they did horse riding and ballet and everything. I couldn't just go out and buy, nice fiberglass stuff. So I went to the wood yard and discovered that a banister rail was like, a £5 or something. So I bought 2 of these and varnished them up. And I bolted them to a fence post. So it was only 16 feet off the ground. But I discovered that if I did this, and at the feed point, because I had some coax coming through the loft, dropped it down, and I put a 4-to-1 ballon there. And that got me on 40 metres. But then I'm here and everybody's telling me, are you on 80? Are you on 80? And I wasn't on 80. So this gets me into strange-shaped antennas. Sorry about the convoluted waffle here. I hope you're just having a pleasant, Thursday night? So what I did is I went back out to the garden. I cut. I just guessed, actually. I just cut a piece out the middle. And this was just literally 550 paracord, holding the two together. And just cut it out completely. And this then became an 80 metre kind of halo. So I was getting on 80 metres. But to get on 40, I would have to tell people, hang on a minute, I'll be back. I'd have to go out. I had these on halyards, and I'd drop them down, climb over the bushes sort of thing, and I'd put a crocodile clip between the two. And that would got me like that, and it would droop down. And that got me back on 40. So that's the beginning of the strange shapes, look. I don't know what I would call this one on 80. It was like a halo. So, I mean, the shape is that shape, isn't it? And I'm still running the 4-to-1 ballon. I didn't seem to have that bad an SWR, to be honest. It was good enough. Maybe I did use the inbuilt ATU then. I don't know. You see, these days I use an amplifier. And the amplifier guys, we love resonant antennas, unless they're big doublets. Because you don't want your amplifier blowing up. You just want to know, I'm better than 1.5 to 1. Go for it, you see. So that was my first triangle. And by the way, I must have had that up 4 or 5 years. It was fantastic. Even on 20. 16 feet off the ground. That's honestly all it was. Maybe 17, I had a lot of fun with that. But since then, I've come across other designs. And by the way, Rowley, ZL1BQD, he's just a good mate of mine, right? He used to teach the radio exam in New Zealand. And as an experiment, he loaded up a 6-inch nail on 10 metres. And they got out and made a contact. Now, and that's just good fun. It's just a great demonstration, okay? So you can get any weird shape antenna to resonate if you've got some inductance and some capacitance to make it all back to 50 ohms and resonant again. What I'm into is the guy who's got a piece of coax and a roll of wire. Now, how does he get that working, right? That's my kind of methodology. That's what I like thinking about. The really simple things in life without using coils and capacitors and also, roller inductors and all that baloney, right? Very often, if you just think about the engineering, you can get to where you want to go without putting another circuit in line. Not every time. So, my favourite little box of tricks for years was called an SG230 Smart Tuner. Smart Tuner, 1T, Smart Tuner. SG230, you plugged in some coax in the bottom, and you basically put anything out, and it just worked. And it worked because when you keyed up and listened to the box, it went, and all these capacitors and loading cores. If you took it apart, it's all loading cores and capacitors, you see. And that's the trick it uses. But it's not going to be 100% efficient, and it costs like £500. So if it's just on one band you're after, well, just find a way of making a quarter wave, because we have to remember, if we've got our loop that needs the 4-to-1 balun, our dipole generally needs nothing. You might want to choke, you might not. Who cares? Okay. If that's your coax, you go out to the shack, you plug that into the radio, and it will just work. The other one you can use, without any sort of tuner or anything else, is a vertical, and all the weird shapes you can get off that. So a vertical antenna that's just directly on the ground. So if it's just on the ground, you're going to have maybe some radials, any length, doesn't matter, honestly. Too many people have been reading a fictitious piece of software, document that was trashed in the end. I'm not talking about the 1930s gospel 256 or whatever it is, quarter wave radials for your broadcast stations, because they pay a lot of money for their their amplifiers and electricity bill and license and everything else. They want every dB to count. But you got to remember that from 16 radials to 120 radials, you're probably only into about 1.5 dB gain anyway. So I don't know why everybody worries so much about it. Anyway, our coax comes along and goes up the spout, and the braid gets connected to the radials, and that's it. So all it is a dipole. We've got one going up there, and the other one is the ground. And to simulate the ground, we put all these radials down. 8 quarter wave radials is the same as 16 eighth wave radials. By the way, Rudy Sevens proved that. N7, I forget his call sign. But we can get interesting shapes from there, you see. So people I've worked out I could actually get on 160 metres from my yard here, my back garden. Because, and I was talking to Mike M0MSN. Look him up on YouTube. He's not only a good friend of mine, he makes some great videos as well. So I told him I was doing this talk tonight, but I couldn't remember what the topic was. So I just ran through all the sort of frequently asked questions I get with him, and we came up with, start off with ATUs and end up with strange shaped antennas. So you can blame him, but that's why we're doing this now. So your vertical, and by the way, I'm assuming that we've got some radials here, on some grounds and whatever. I'm not interested in ground rods. That would, we start converting all this into some sort of lightning conductor. Just after some radials lying on the lawn, maybe pegged down, but that's fine. So if you think about it, if that is 10 metres long, we know that that's going to get us on the 40 metre band. Now, to get on 80 metres, we could do a little trick, is that we could go up, we could make a little coil, and then carry on again. So we could make this thing, we could force it from the 40 metre band down to the 80 metre band. And by the way, the more efficient coil is somewhere up here, but the trouble is, the further up it is, the less use it's got as well. I did my DX Commander Rapide, right? I don't know why it's got an E on the end. Okay. Talk to my marketing people. But we took a 7 metre pole and we put 13 turns on about just round the pole. And we made that look as if it was 10 metres long as well, because that was resonant on 7.15. So you could quite easily make them shorter and shorter. And I'm sure you'll remember, if you don't remember, you might have seen some pictures that in the old days, before 2 metres was big, a local chit-chat used to happen on 160 metre band. and people would make dedicated antennas with little coils. And it would be really sharp. It would almost work that frequency and 5 kilohertz each side, 160 meters. And by the way, if you search on YouTube for 160 meter AM mobile, or I can't remember what it is, I'm sure you'll track it down in the end if you're aggressive with your searching. I've actually heard recordings of people driving to work, with a net controller, and they're all chatting away on 160 meters. 160 meters is such a tragedy that we don't use it more for this local stuff, because although it's not as crystal clear as 2 meters, there's people getting great ranges with it. I digress. So what can we do to make this thing appear even longer? Am I running out of paper? I think so. I'm here at 7:30. Well, we can do things. We can do the inverted L, and that's quite normal. And by the way, there's a big station on top band who uses inverted L. So I don't know how big these two are. It doesn't really seem to matter. I've tried all sorts. I've gone up for 80 meters. I've gone up 5 and gone along 12.5. I've gone up 7.5 and gone along less. And the modelling doesn't seem to make much of an impact what you do. But what you could do, I'm just for fun now, you could go up 10 meters. You could go along 10 meters. By the way, that will sag. Don't try and make that straight, because the tension on these will be quite high if you've got another pole here. And you can come back down 10 meters. Now, that's not quite long enough to get on 160 meters. Don't touch the bottom here, right? That just becomes a hot end. But you could put a coil anywhere in here, Just put a little coil there. And eventually you would find it would tune on 160. Now, that's only 10 meters wide. 10 meters high is a bit of an ask, although you've got a chimney very often. So you're going to have to get creative. But you can get potato on it. Potato being because the potato is generally a funny shape. So you could go up, you could come down, you could go along, you could go over there a bit and down a bit and along a bit more, right? Doesn't... Sometimes, I think the thing is, we see in the books the perfect antenna, and we forget that my first dipole, if you remember, this one, it came along the fence. And I used to worry about that. I used to ask people, do you think it'd be all right? Yeah. The high current, remember, where most of your RF is actually coming from, is up here. This is just sort of the piano tuner doing his work, right? All the RF's coming off the top. So don't worry about that. What else was I going to do? Potato shapes. Okay, so, the loop is, for a start off, if a dipole is that big, a loop is half the size. Or even less, actually. But it doesn't have to be square. Doesn't have to be triangular. You can make it the potato loop. You've got a tree over there and a tree over there, and then one a bit further here, and then back to the chimney and whatever else. You still don't need an ATU. As long as you're prepared to have one of them on a halyard and you just drop it down and join it again. I must make a video, actually, how to join two wires together, because I've seen a lot of messes. There is, I think they call it the AT&T wireman's join, where you get two wires, cross them over and just twist them around. Bit of solder, if you like. I didn't. All my antennas that I've made up here, because they're under tension all the time, I don't know why, I just used to put a bit of tape around them. The other trick I've done, because you've got to remember, most of the antennas we ever put up, apart from, I forget what his name was, Justin's made a big investment to put some proper hardware on his chimney, and it's up at 35 feet. The rest of us who use bits of wire, very often we're like, oh, do you know what? I'll give this a go. And if you over-engineer it and do it all properly, chances are in 18 months it's going to come back down again, because you're going to come up with a better idea. You're an experimenter, because that's what this hobby is about, isn't it? It's experimenting. So if I can leave you with the fact that just the book, if the book says an inverted V is an inverted V, to throw the book away, you can literally come up with any shape. The only kind of real law there might be would be if that's 90 degrees there, if you close this gap too much, it will eventually, if you think about it, it will go up and come back, and it will look like balanced feeder, okay, and it will cancel each other out. So 90 degrees is probably the maximum you want to go before you start to incur some losses on your inverted V. Beyond that, you can do anything with these wires. You can go over there with one of them, over here with the other, because unless it's half a wavelength, which on 40 meters, come on, well, you do the maths, is pretty high up. Beyond there, most of the time, for your average Brit and your average English or Scottish garden, or Welsh or Irish, even on 20 meters, most of the time, all we're doing is creating a bubble of RF. Unless you're into VHF, and you've got Yagis and stuff. But even a low to the ground Yagi, like a hex beam at, 20 feet, most of it's bubbled. I know some of it's pushing in that direction it's supposed to go in, but very often it's just bubbling up. It's not high enough to start operating like a Yagi. All right? There we are. I've waffled for half an hour or so. Let's, people want to ask me questions. Let's have some dynamic chit-chat, shall we? I've got a vertical which is, I think it's 9, plus or minus a little bit. It's 9.5 meters long. And I get my 40 meter antenna, and to get it to tune on 40, I used to take this wire up and add a little bit to the top, and it would sort of droop over and whatever. I just got fed up with this one day, and I just cut in fact, I cut it at 11. No, I didn't. It was 11.06, because after I did this, I measured it. I cut 11.06. I went all the way to the top, and I went back down again. All right. Now, what I was getting when I was getting my tune on 40 meters, I was always getting a 21.6-ish on the 15 meter band, and it annoyed the hell out of me. When I did this fold over, I got a perfect tune at 7.15 whatever, and then I got 21.06 with the fold over. Now, I'm not going to discuss with you why that happens. It's capacitance and loading, height above ground, a few other odds and ends. But I discovered I could tune this length to make a change on the 15 meter band, and it changed the 40 meter band 3 times as less, which means there's an optimum size here where you can probably get, there's hundreds of customers out there with a DX Commander who are perfectly happy in the US anyway with 7.2, 7.25 and 21 meter band, because what they get is probably 21.2-ish, something like that. Now, that happens exactly the same as a dipole. So I'll just draw one leg of our dipole, the other one goes off here. You can bring it back on 40 meters, and you'll get the similar tune business on the 15 meter band. Somebody called it the boomerang match, and that was the answer. So there, to be continued.
Okay, well, we thank you, Callum, for this very interesting and unusual talk.
Unusual is the most important thing.
Yeah, we certainly promote experimenting as much as anything, which is, I think, is a key to the hobby, isn't it?
Give it a go, as Rowley says, my mate.
Okay, thank you very much. I'm going to stop
the recording
now.
Recording stopped.